video, we're going to check the general term of the geometric progression. The general term of the geometric progression is given by Tn equals to A multiplied by R to the exponent of n minus 1. Yeah, this is where A is the first term of the sequence. R, it is the common ratio, which is given by T2 over T1. You don't have to say equals to T3 over T2 because we're given that this is a geometric progression. We don't have to prove it. And then n is still the nth term. Then Tn is the general term. So let us try an example and see how we can apply this. Let's erase this first. Oh no. Alright, thanks. Let's say we have a sequence which goes 4, 8, 16, 32, and 64, and so on and so on. This is a geometric progression or a geometric sequence. We are told, we're given. So we don't have to waste our time trying to prove whether it's a geometric or arithmetic. So this one is a geometric progression. The formula to remember, the question is to calculate Tn. We have to calculate Tn. So let's start by writing the formula of the Tn. A times the n minus 1. This is where A, it is the first term, and it's obviously the T1. The first term of this sequence, it is 4. R is the common ratio and is given by T2 over T1. In this case, the term number 2, that is 8 over term number 1, which is 4. And then this is obviously is true from your calculator. Then we substitute the formula. Tn is equals to the first term, that was 4, multiplied by the common ratio 2 raised to the exponent of n minus 1. That's how it is. Then you prove it using your calculator. Try to check. Let's say term number 1, 2, 3, 4, 5. This is term 1, term 2, term 3, term 4, then term 5. Yeah. Term 5 is 64. Let's see if we will substitute term number 5 here. Will we get that? Term number 5 followed by 2 to the 5 minus 1. Then you can press your calculator as well to see 4 times 2 to the 4 times 2 to the open bracket 5 minus 1 is indeed 64 on a calculator. So which means we got it right. So let us try one more example. Let's say we have a sequence 3, 15, 75, 3, 7, 5. And we also given that this is a geometric progression. So calculate Tn, or the general term. Start by writing the formula. Tn is equals to A by n minus 1. Then A, it is the first term. Remember, in the first term it is sequence T1, T2, T3, so forth. T1, which is 3. And then D, oh, this is not D, this is not arithmetic, this is geometric. Geometric, don't have D, instead we have R, the common ratio. It's given by T2 over T1. And I'm still mentioning this once more. The reason why we don't have to say T2 over T1 equals to T3 over T2 is because we are told that this is a geometric progression, so we don't have to prove it. Then term number 2 at this second, that is 15. Term number 1, this was term number 2, T2. Term number 1 is 3. 15 over 3, that is 5. Yes. Then we substitute the formula. First term, that is 3 times the common ratio, this is 5, to the exponent of n minus 1. So we don't have to put the brackets, you can just say 3 into 5 n minus 1. Then I will prove it first. I usually like proving with a number which is on the last. T3 and number 4. Let's just see with T4. This is the general trend, remember. T4 is equals to 3, 5, and this is 4 on the n. Where this n we substitute by 4 because we're looking for the T4 minus 1. And then these, okay, let's see on the calculator. 3 times 5 through the 4 minus 1, which will to the 375. That's indeed 375. So we got it right. So you do examples on your classwork book or on your question papers. So if there's a question which is most challenging or you just want to discuss it, write it down in the comment section, then we'll discuss it. Thanks.